Hello everyone, this is Joe Brewer here at Bioparque Moncora in Barrio Chara, Colombia. And today what I want to show you is how we are creating a pass-through for the water retention system. And you may recall that we have a approximately 1 meter deep channel that's right here that comes in from the road, and it's 1 meter deep because the road is below us, and the rainwater will come in from the road and enter this channel. And then as it comes in this channel, well, you can see it here, the channel continues and enters into our water retention pond. And then the problem quickly becomes that if the water comes in at this level and fills this pond, then it would backflow back out to the road and create erosion as an overflow by running down the road. And this pond is built so that the water can enter and it doesn't fill all the way. So I'll show you how that works right here, that the water enters, and in this spot right here, that's the depth of the channel. Let my hair out of your way. And that means the water comes into a depth of about, well, it comes down to somewhere here in the middle. And then we're able to fill the water to a line, something like this. And so what we needed to do is create an exit channel for the water to go out. And today we're using an A-frame, which is a very old engineering and landscaping tool. And you can see here that we have an exit channel and we have our A-frame sitting in it. And the exit channel runs out and goes around the curve and goes to a downhill space where we'll be able to build another water retention space. So you can see here that we have the main retention pond, and let me angle it lower for you to see. So the main retention pond, and then there's our A-frame in the channel that's going out. And now what I want to show you is how we measured the depth of this exit, because we wanted it to be exactly the same as the entrance. So the water enters, fills all the way up to the maximum height, which is the entrance level, and then it exits at the same level with the forward flow of water pushing it out. And so what we did was here at the entrance to our channel, we put a pole. And we stood it there, and we took a piece of string, and we brought it over and attached it to this pole right here. And then we used a level, which measures if something is horizontal. We measured the string. When it's horizontal, we made a mark. And then we measured the depth of the string on that end, which at that time was dropping down 42 inches. And then the depth of this, which dropped down less. And so what we knew is that we needed to go to the bottom of the pole and go continuing to 41 inches down, which turned out to be that we needed to go 15 further inches. And so what we did was we just took here where you can see there's the pole, and at the same level over, we measured down 15 inches. And now we want to be sure that that line of the canal is level, and so we're using an A-frame. Now I'll show you how the A-frame works. So I'm kind of leaning it here with my pickaxe because I'm here alone today. So I'll try not to touch it and knock it over. But I want to show you is that here on the A-frame, just, as you can see, it's shaped like an A, has a piece of string attached to it right here with a rock. Oops. And the rock, yep, I knocked it over. That's okay, because I can just lift it up like this and move my pickaxe to show you. What I want to show you is right down here, I have two lines, and when the A-frame is level, the rock, which acts as a weight, will hang right between those two lines, and that tells me both ends of the A-frame are at the same elevation. And what I'm doing now is I'm going along and measuring to be sure that the bottom of this canal always stays level so that water can exit, and as the water exits, it will be able to move into this downhill area where we'll build other water retention spaces. And here what you can see is as you look at this, that we have the main water pond, the retention pond there, and then this curve coming out, which means we create the effect of the water coming in, making a curve, and then curving out. So we're already starting to make the pattern of a serpent or a snake going down the landscape. And so our idea from here is as the water exits, we'll be able to dig another retention pond or a contour swale, which is just a ditch that is measured at the same level so the water spreads out and sinks. And then we can make this snake-like pattern going all the way down the hill for this entire hectare of land. And so I wanted to show you this, how we're using the A-frame to measure our depth and be sure that it's level inside the channel, and how we used two pieces of wood and a string and a level and a marker and a measuring tape. And we measured the height of the entrance depth to measure the depth of the exit depth so they would be the same. And so now we have this beautiful water retention space that is nearly complete for this first stage. And here you can see the whole thing is there's our water retention space, and the water is going to exit right there and go out and go down. And so that's it. That's how we are building a snake-shaped or curving path for water to move through the landscape, to be held and infiltrated into the land. And as we've shown in several other videos, we're planting trees and we're putting undergrowth of native plants and various things that will hold the water here when it comes. But this is the shape of the system that is going to bring the water in from the rain and feed the entire food forest. So that's what I wanted to show you today, was how we're using the A-frame to measure a level exit, and how we use 2 pieces of wood and a string to measure the exit depth from the entrance depth. Basic engineering, basic trigonometry. You could do this with middle schoolers if you wanted, just very basic mathematical reasoning. Even younger kids could learn the concepts. So I wanted to show you how simple it is to use objects that are all around you, sticks, string, and rocks, to be able to measure everything in your water retention space. So I hope this inspires you to go and regenerate some degraded land where you are. And thank you for watching today.